what I want to do in this session is hopefully inspire a little bit of creativity amongst everybody in the room with using the ArcGIS runtime SDKs. So I'm going to do that by starting off by answering three fairly important questions, really. So what ArcGIS Runtime is, how you can get started, and the resources that are available for you to be able to create these applications. And we'll also go through what you can do with it, which I can't really do in a lot of justice in just 20 minutes, but we'll try and back that up with some product demonstrations, looking at some key bits of functionality, including the offline capabilities of Runtime, which is very important to app developers working with this technology. I'll talk a little bit about licensing of the product and how to look at that. And we'll finish off by looking at a new area of development we've been working with, where we've been integrating runtime 3D rendering technology into game engines. So starting off with the first question, my elevator pitch. The Runtime SDK, it's basically a set of modern SDKs for allowing you as developers to put mapping and GIS functionality into your own apps. So that could be a brand new application, or it could be an existing application you have in your organization that you want to sort of bring some spatial awareness into. So like a lot of the other technologies you've been looking at today, it's another client to the ArcGIS platform, but we also support the ability to be able to draw data in from OGC formats like KML or WFS, for example. So you don't necessarily have to be brought into the Esri stack to be able to use this technology. So we're about applications that run natively on your device. So we're not talking about web applications here. Now, in terms of deployment, you can have runtime applications that are deployed to mobile devices, so Android or iPhone, and also the common desktop. So we support deployment to Windows, Linux, and Mac. Now, this functionality, which is the same across all of the deployment and APIs, is available for Android and iOS for sort of writing dedicated applications for those platforms, but we also have APIs for Java, .NET, including Xamarin and Qt. And actually the latter three there open up the possibility for writing an application once and being able to deploy that to different platforms, both mobile and to desktop. So in terms of how you get started, probably the best place to go is to our developers website, developers.arcgis.com. And actually, that's the first port of call, regardless of the developer technology you're making use of here. So if you go into the documentation tab, you've got the documentation for writing JavaScript applications. But we're about native runtime apps, so these are for mobile and desktop APIs. Let's just go and take a look at that for iOS, but I will sort of reiterate the structure of the documentation and the capabilities of all of the runtime APIs is exactly the same. So just looking at iOS, if I sort of scroll down a little bit here, the first thing you'll notice here is we've got a set of very detailed step-by-step tutorials that will take you through creating your first application, maybe putting a polygon in that app. They're all building upon each other, but they're very detailed. So in terms of an iOS developer, if you've never used Xcode before, there's sufficient detail there for you to be able to get going and create your very first application. And then to build upon those basic building blocks, there's a lot of concept documentation that explains how to build in other common use cases into your apps, like working with utility networks or spatial analysis. There's a whole host of things there. Now, to complement that, we have a set of sample applications that we've written. And these are all available in GitHub, completely open source, so you can compile these and deliver them to your devices and get a feel for how they work. And if you like that functionality, then just take the code out of that and put it into your own apps, because you can be confident that the code that's been written for these is best practice for implementing that particular use case. Now, each of the APIs, in addition to the resources we've been looking at here, also have an open source toolkit. So these are a set of UI components that allow you to bring in extra value-add items like, north arrows or scale bars. And because they're open source, if you don't quite like the functionality you've got there, you want to style it in a slightly different way, for example, then just pull the code, create a fork, make a modification, and then you can deploy the modified toolkit component to your own app. So what can you do with the APIs? Well, again, I keep saying 20 minutes is too short a time for this, but start off with the visualization side of things. You can visualize the data in 2D maps or 3D scenes. And then once you've got that visualization, you can build upon the GIS capabilities and the APIs. So this consists of things like, I don't know, routing or geocoding, which is kind of address location, various sorts of spatial analysis. So maybe you're working with utility networks and you want to be able to do a trace to identify what happens, who gets affected if a fuse blows in a distribution network. It could be 3D line of sight or view shed, and many more. In terms of the data that you can work with, it could come from server-based sources, so it can come from ArcGIS Online or any of the Esri services, but also we support the OGC services like KML or WFS or WMTS, for example. And of course, we support file-based data. So file-based data applications enable you to be able to run offline when you don't have any network connectivity. So you could be bringing in map packages that you've created in ArcGIS Pro, or it could just be a shapefile if you're still working with those. So I think probably the best thing to do now is for me to hand over to Jen, who's going to do some non-slide demonstrations. We'll take you through how to write a very simple application for an iPhone and deploy that and get it working. And we'll have a look at some of the key functionality inside Runtime, including our offline workflows.
Great.
So
onto my laptop, please.
Over to Jen.
So again, 20 minutes is very short, so I'm going to go through some kind of the basic things. And first of all, just how to get started with writing an application. So this is based on the Display a Map tutorial, which is available on the developer's site that you've just seen. So these are really easy to get hold of and to follow along with. So I've got an Xcode project open here. I've got the View Controller class open, and I'm just going to go through the main things that you add to kind of get started with Runtime. So initially, I've got my import statement here to get access to the API, and that enables me to use those ArcGIS runtime classes within my app. So the first one I'm using is a map view, and the map view is like the UI component that holds a map, and that handles all the user interactions like clicks or taps on mobile. So the next thing I create is an ArcGIS map, and the map is the data. So that holds everything that's relevant to the functionality of your application. So whether it's feature layers or feature data. In this very simple application, I'm just applying a base map style to the map. So then I set my map onto my map view, and that's how I kind of link those two up. And in this app, I'm also just creating an initial viewpoint, and that's where the map is going to load when I load the app. So I'm just going to bring up the simulator. Sorry, staying on here for a second, yep. And open up the little application here, and here you can see a map of where we are right now. And I can interact with that. So the key takeaway here is this idea of a map view or a scene view being the UI component that holds an ArcGIS map or an ArcGIS scene, i.e. the data. And that's the same as kind of been touched on for all the platforms. So whether you're writing for iOS or whether you're using Java or any of the tools or the applications, it's the same principles. And the other thing that you'll need to do is to set an API key. And there's instructions, again, on the developer's website for how to create your API key in your developer's dashboard and also how to then set it within your application. So I'm just going to switch over now to the physical iPhone. And I'm going to show just a few examples from this samples application. And this is something that you can download for free. So this is available in the App Store. So do feel free to have a look at this in your own time. Same for Android and all the other platforms. You can get hold of this. So the first one I'm going to show is a 3D application. And in this case, I'm flying through the Grand Canyon here. And you can clearly see the difference in the scene as we can see the topography from a surface elevation being applied in the scene. And there's various other settings with a scene, such as camera settings here. And next, I'll just do an example using some of the routing functionality. So in this case, there's a number of hospital features you can see on the map. And if I tap somewhere, the app's going to calculate the route to the closest facility from where I tap. And finally, we've touched on one of the main kind of benefits of using native applications is that you can make use of the hardware and the peripherals associated with a device. So in the case of iOS, you can use ARKit to create augmented reality apps. And assuming all behaves itself here on the tabletop, I can use this to placed a 3D scene, and everyone in the front row can give a little wave. Here we have downtown Philadelphia falling off the table. But it's quite a fun and intuitive way to kind of interact with data. And there's more kind of things you can do with AR, which is all available in the documentation. So switch back to the slides. So with the exception of AR that we've kind of just touched on, as you'll have seen, most of what we've kind of talked about can be done with JavaScript and web apps. So the main other benefit of using Runtime is offline editing. And there's a range of workflows for offline work that depend on your use case. So you can create read-only mobile map and scene packages in ArcGIS Pro and sideload these directly onto your device. And these include feature data, base maps, transport networks, which means you can do things like routing and geocoding and analysis all whilst offline. Mobile geodatabases support local editing, and since the most recent release of Runtime, you can also create mobile geodatabases directly from your device. So that's kind of like a single user workflow. So you're working in Pro, you create the data you need, drop it onto your device. But if you're in an organization with many users who access the same data, you can author web maps in ArcGIS Online or on Enterprise and enable them for offline use. And that means that data can move seamlessly from the cloud to all the devices that use the data. So a scenario here would be if you have a lot of workers who go out into the field during the day and maybe they're away from network connection in remote areas. They can download a map package to their device at the start of the day, go out into the field, perform all their editing and analysis, and then come back online at the end of the day and synchronize all their changes up to the server, and in turn, synchronize changes that colleagues have made during the day since they last had their connection. And there's two main workflows from Runtime to kind of support this, which I'm just going to use a couple of samples again to help me explain. Just make sure I bring up the right one. So first of all, we have the on-demand workflow. So in this case, I'm connected to a service here, so this is online. I can find the area, so say I'm working in this sort of park here, and I can then generate my geodatabase and my map package, download it to my device, and head off into the field. But you can imagine if, say, there were thousands of my colleagues doing this at the start of the day before heading out, this will put considerable load onto the server, and that's because the mobile geodatabase is being generated on the fly. And so there's actually an alternative workflow that kind of gets around this, and it's called the pre-planned workflow. And in this case, the administrator of an online map can predefine areas that can be taken offline. And so that means that the mobile geodatabase generation is all already done in the back end, so you're just downloading it to your device. So again, in this situation, rather than me choosing the specific area, I have these options that an administrator has predefined. So I would choose the area that I'm going to go offline, and it will download a lot more efficiently. And then this is the example of it being downloaded onto my phone. So I could now go offline into the field, do my edits, and then synchronize at a later point. That's back to you.
Thank you. So hopefully that's given you some good ideas of at least some of the capabilities of Runtime, especially these offline workflows, which are really important to field workers. This is really where Runtime comes into its own above writing a web application, which would not work if you were working offline. So once you've created an application and you've decided that it's ready to go, before you can actually deploy that to your organization or you can make it go live to market, you need to consider licensing the application. So Runtime has 4 levels of licensing, starting off with a light license, which is free to deploy, and there's increasing levels of functionality and cost associated with basic, standard, and advanced. Now, I'm not going to go through that yet. I'll point you at a web page here that explains that, but just give you an idea. The light license, which is free to deploy, is really well suited to, say, a citizen science data collection app. So if you wanted to write an app which would enable members of the public to record the birds that they've spotted in their garden in the month of May. As long as the data that you're working with is all publicly available, then you can use a free-to-deploy license there. Now, technically, there are 2 ways of licensing your application. So first of all, we have the named user method. So if you're already a user of a portal, so this could be an organization in ArcGIS Online or your own internally hosted portal, all you have to do with your application is programmatically log into that portal, and then that will unlock the capabilities. And actually, as you're already subscribed to the ArcGIS platform, there's probably no extra cost in actually deploying a runtime application. But we recognize that not everybody is bought into that technology. You may be using OGC data. The license key is the way to go. So you can buy a deployment pack of licenses from Esri and burn these into your application to be able to deploy them. Okay, so I'm going to move track a little bit here and talk about an area of development we've been working in where we've been taking the 3D rendering capabilities of Runtime and integrating those into game engines. So for us, this is creating two new products. So this is the Maps API for Unity and Unreal Engine. Now, we really see this as being the next generation of 3D GIS for developers. So you may be thinking, why game engines? Why are we sort of experimenting with this technology? Well, this really does open up a lot of possibilities from a sort of a development point of view. So it gives you very easy access to those premium rendering experiences. So I'm not just talking about looking at things on a flat screen here. I'm talking about being able to write extended, virtual, or augmented reality applications. Now, of course, the game engines have got very rich APIs that give you access to things like physics engines, animation, or special effects, where you can make your scene look like it's raining on a sunny day, just so you can visualize how things will look. But it also has a very good cross-platform development and deployment story. And of course, there's a very good user-developer community to sort of help you along your way here. Now, this is technology that we currently have out in a beta format. And actually, there's a surprising number of users who have this. So we've had about 5,000 subscribers to this worldwide from a wide range of industries. So it's not just games developers who are using this. People who work in urban planning or defense or public safety or a whole host of other types of organization have been working with this technology. So in terms of availability, so it's currently in beta. We have a 1.0 release of this available next month. Unity is coming out first, followed by Unreal Engine about 3 weeks later. We will have equal support for Unreal Engine and Unity. So from a GIS integration point of view, there's nothing to choose between the two from our points. We're supporting developers who are working with Windows or Mac IDEs, and that gives you the ability to deploy to both both mobile and desktop technologies. Now, the SDKs initially are not going to be as functionally rich as the rest of Runtime. So we've really focused on the data sets you'll be wanting to work with to do that 3D visualization. So we've been integrating the elevation layers, the tiled layers, and of course the scene layers that enable you to be able to visualize the 3D scenes. So I'm going to switch over now to an app that I've started writing in Unity. There's a couple of different approaches. It's very similar to in Unreal Engine, but in Unity, I could have written everything in code. It would be in C# in this case. But in this case, like a lot of developers, when they start working with this, the basic building blocks are made up with components. So the data that I'm working with here is visualized inside an ArcGIS map view component. See, the classes are very similarly named to Runtime here. And then to specify the data that I'm working with as a subcomponent of that, I've got an ArcGIS map. So you can hear I've specified the base map and the elevation. And at the bottom here, I've got the URL for the scene service that I'm working with. And then I've got a camera component, which specifies that initial eye in the sky where I'll be visualizing my data. And then, I'm not very good at game controllers. Oh, I've messed that up. You can sort of interact with the display here. So once you've got that, it's at that point you can then make use of the power of the game engine technology for building up other visualization techniques. You can sort of change the renderer of this building to, if you wanted to revamp it, to get a view of what it would look like. You could visualize this in different weather conditions. You could sort of do some urban planning on a new park and sort of place some trees and be able to sort of visualize what this looks like with people standing around a table looking at this on an extended reality table. So just using that urban planning example gives you some ideas of the potential for this technology. So this brings me to the end of this fairly short presentation where we've been looking at runtime. So remember, it's a set of APIs for allowing you as developers to bring mapping and GIS functionality into your own apps. We've been looking at some of the capabilities, 2D visualization, 3D visualization, analysis, and that's all important offline data collection workflows, licensing, and then finally that game engine integration, which we're going to be releasing next month. So with that, I'll hand you back to Gilly. Thank you.